Aside of the simple delay you've seen already, this one, which has separate delay times and dry wet setting and feedback for each one of the channels, we have, let's say, a ping-pong delay. Now, a ping-pong delay uses the same delay time for both of the channels, and there's a reason for that. The reason is that every time the delay repeats a sound, it actually repeats it only on one of the channels, so left or right. So first of all, it's going to repeat on the left, and then on the right, and then on the left, and then on the right. So every time it's going to repeat it on the alternating channels. So first left, then right, and every time introduce this much delay. So with so much feedback, filter, let's try that out and show you what it sounds like. Okay, aside of that, having that actual feedback going left, right, meaning that every time the signal passes through the left channel, it is taken into the buffer, recorded, delayed, attenuated, and played through the right channel. And then everything playing on the right channel is taken back, recorded, attenuated, delayed in time, and then played to the left, and so on in a circle, just like this, going into the left, playing back, of course, because we have the dry, staying out, and then going into the right one, going back into the left, and this is how our circle goes crisscrossed, hence the name ping pong, going left, right. Now, in this delay that we have right here, we also have a filter. Now, this filter houses a low pass and a high pass filter at once, and we can just make it wider and see narrower, just like a band pass filter would, as a band pass filter is a combination of low pass and high pass at the same time. So we can filter out the actual feedback that we are getting. We have the original and we have the feedback, which is the actual wet piece of the signal, wet signal. Now, let's see what that sounds like if we actually filter this delay. Let's hear that. Let's filter that even more. See filtered, open. Or like this, only the highs. So these are some of the things that we have in our delays introduced. So filters, ping-pong functionality, left and right. We also have a filter delay right here in Ableton, like this. So this filter delay has a left plus right delay on the center, which is actually going to repeat both of the channels. So the left and the right channel, mono. Now we also have the left and the right separately. So we can just do this. Let's turn this one off, turn that one off, like that. Turn the entire line off. And now let's hear what this left one sounds like. So it only repeats the signal on the left channel. Let's see this one. Yeah, this one is only on the right. Now let's see what this one in the middle does. So this one is mono, repeating everything in the center, adding up left and right channels together. So we can repeat the left and the right channels independently of each other, filtering them out, of course. You see all the same controls, and we can pan those left or right, so I can even switch them out. Let's say repeat the right channel always on the left and repeat the left channel always on the right. So whatever comes in as dry is always going to be repeated normally, so the left channel goes out on the left and right one on the right, but the feedback, the actual repeats of those that the delay is going to produce, like this, are going out on opposite sides. So I can even control that. And as I said, I also have the filters on all of those. Now we have many different delays that actually introduce like this, filters, maybe even time modulation that we can use. But they're nothing but just simple delays that have different routing for the feedback, like I've shown you. So a simple stereo delay or even a mono delay that just has, like in this filter delay, just this middle one. So a mono delay It just goes out. Both left and right are repeated on both left and right. And we have the stereo one, which was like that simple one that we had in the beginning. This one has the filters on both. So we have the left and the right separately with the times and with the actual control of feedback, with the actual control of panning, volume. So we have the mono, the stereo, the ping-pong, and we have special things introduced like filtering, sometimes even distortion. Sometimes all of these delays are modular, so we can actually introduce distortion in some of the systems, in some different digital audio workstations. So they could be quite complex and quite simple. Now, this kind of a delay effect where we actually have some feedback, some repeating, like we do here, like this, is the most common one that you hear in songs. Always, let's say after a vocal phrase has finished, and then you can hear that last piece of the vocal repeating, you can have that. But what we also could have is, let's say, a delay on only one of these. And let's say we forget the dry. I'm going to use this simple delay. And let's say I'm going to not play the left one. I'm just going to let the wet through. No feedback. So what I'm going to do now is I'm going to delay one of these channels, only the left or the right, by let's say 19 to 20 milliseconds, something like that. And listen to the stereo effect being produced by that. And without it, it makes the sound so wide and so stereo, so around you, and that's a beautiful effect. It's called a Haas effect, where one of the channels is actually being introduced a tiny bit in milliseconds, a tiny bit later, just like here, and it makes the sound really more stereo, much more stereo. The problem that we might get out of this is once we take this sound and add these two channels, the left and the right, add them back together into mono, now that could cause some phasing issues. And you should always be careful, but more about that when we get to mixing and mastering. For now, it's a really interesting thing that we can do with a delay, aside of having that normal delay with the feedback kind of an effect that we are all accustomed to.